We're going to go ahead and get started. Who am I? Besides being crazy, I am KW5GP. I am now a retired network engineer and technology consultant based in Memphis, Tennessee. I was first licensed as WN4FTX back in 1973. I'm the author of ARRL's Arduino for Ham Radio series, Elector's Arduino for Radio Amateur Applications book that just came out, QST articles and product reviews. I also show world champion Maine Coon cats. As you can see here, this is Godzilla. Oh no, it gets better. She is indeed a world champion Maine Coon show cat. And as you can see, she's definitely a handful. And those of you that know me have seen me on w5kub.com. This is my current pair. Of course, this is why it takes me forever to build a project. I have to find a way to get the enclosure out from underneath Godzilla, and then I have to pay rental fees to use the soldering iron. And if you want those wire clippers, they come extra. But she definitely, you have to work around them. Believe it or not, they have never been burned by the soldering iron. And but they are definitely underfoot. But just like anything else, there's more. We got a new one. This is Sasquatch. He is a 4-year-old Maine Coon boy. And you remember seeing Godzilla in the first picture? He's a 1/3 bigger than she is. And he's only 4 years old. Maine Coons grow up until 5 years. But we can't tell him he's adopted. And did I say they're huge? In this screen, this is a 42-inch TV to give you context. And he's still got another year growing to go. But that being said, you're not here to see the cats. You're probably dog people too. But today, I am going to answer that one big question we've had in life. No, it is not 42. We're going to prove that wrong today. Those of you that have been coming and seeing my seminars for years, I've been saying, you ask me what to do, what I can build, what to do after I get this thing. And I have been answering typically, think of a project and go build it. It's that easy. And yes, it really is. But that's not a fair answer to those of you that really are trying to learn. And so, with the demise of places like Radio Shack and STEM and electronics classes and schools and universities, I mean, where can you find this knowledge? It's really not out there. So this presents a really big hurdle to you, those of you wanting to learn how to do the microcontroller thing. So where do you acquire these skills? The hint, we're going to find them in amateur radio. What parts and tools do we need to get started with this? There's not very much in the way of starter kits and things for the Arduino out there unless you go it alone. But don't be afraid. Along with learning the microcontrollers themselves, it will help you to learn some basic electronics. Go to sparkfun.com, adafruit.com, and others. The ARRL handbook is a great place to learn some basic electronics. Once you understand the basic roles of these various components, then you can learn how to combine them to create your own microcontroller projects. And don't be afraid of wiring something wrong. Smoke is part of the process. It really is. If you're not blowing something up, you're not pushing the limits. This is why the parts are cheap, okay? We're not afraid to throw it, The parts in my bins, whenever I blow up a part, you can literally see the big ones push the little ones to the front, say, take him next. But the thing is, they're inexpensive parts. You're not killing yourself. You're not hurting anything. So don't be afraid to make a mistake. And a lot of these components are very forgiving. So even if they're not, they're inexpensive. So you haven't hurt anything. And grow as you go. I recommend starting out with the Arduino Uno or Nano. Buy some basic components, but don't go overboard. And we'll show you some methods there. A basic component assortment goes a long way towards building products. You will actually find that when I'm building things, I use almost the same parts over and over and over again. the same value resistors and capacitors. So a basic component assortment will go a long way. You can get these from eBay, AliExpress, Banggood.com, just about anywhere. If you want to spend more money, you can go to Jameco or DigiKey, but we'll talk about that in a minute. And that's basically parts is parts. It doesn't matter where you get them. We're not playing with mil spec, top of the line stuff. When it comes to our projects, the parts really are pretty much all the same. So it doesn't matter where you get them. We're hams. Do you want to spend a little or do you want to spend a lot on your parts? I'm cheap. You know, I go to AliExpress and wait a few weeks for my parts to come in. I get a bag full of resistors for 25 cents. But eBay, Banggood, AliExpress, I've been getting parts from them for years and really haven't had much in the way of problems. Next thing, learn how to solder. Yeah, if it smells like barbecue, you have done something wrong. But ask your fellow hams, your club, to run seminars on how to solder. It's not that hard. Some ham fests, such as the Orlando Ham Fest, actually have seminars on learning how to solder. And Joe Eisenberg did a forum yesterday. You can always catch his forum on kit building, and he can point you in that direction as well. And for your test equipment, as with any hobby, you can either spend a little or spend a lot on our tools and test equipment. It's the same way with our radios, isn't it? We said we just bought a $200 radio. We usually have to add a zero to that price tag, but we don't tell anybody. But you don't need the best of everything to build your basic microcontroller projects. In fact, you don't really even need everything. A voltmeter will cover just about everything you need to do. And as your skills progress, just like with the radios, you're going to want more and more stuff. You know, you need that digital SWR meter, that automatic tuner, and oh yeah, that Ameritron amp. Gonna have to do it. But to get started, you don't need that. But in addition to a standard multimeter, there are a few tools that at some point you're really going to want to have. You'll want a good temperature-controlled soldering station. The one that's shown here is like $50 on AliExpress. And get one that has a hot air gun. You'll need this if you ever want to solder surface mount components. Or if you're going to heat shrink, they're wonderful for doing heat shrink. I don't do surface mount soldering. The last time I did surface mounts, I think the fire department asked me to stop. But get you a component tester. These are like 10 bucks, and they will test the component, tell you what value it is, even give you some basic parameters about it. This way, you don't have to read the capacitor color codes, or the numbering and the resistor color codes. When they went to that 5-band resistor code, I just gave up. I just said, no, stick it in the component tester, and off you go. It will even help you identify semiconductor components and even those unknown parts that you find out at Hamfest flea markets. You can test and it'll tell you what it is. These are about 10 bucks. You can find them online. A lot of Hamfests have them. I haven't seen any here. And as you notice, mine comes with the cat's claw security option. Nobody's stolen it yet. I found body parts everywhere, but nobody's made it out with it. You'll want an oscilloscope. While you don't really need an oscilloscope to build and troubleshoot your projects, they really do make life easier at times, and eventually you'll probably want one. There is a group here, Unity, that had some really good scopes, and they're very well priced. They're like $200 a piece, and they're not really that expensive. Amazon's got a 2-channel digital storage scope for 180 bucks. And you can also find the inexpensive older style scopes in the flea markets here. I mean, they're all over the place here. So you can get a scope. Another thing that you want is a logic analyzer. Think of this as an oscilloscope for digital signals only. This will show you the signals, the timing relationship between all the various digital signals. Since you've got like 16 I/O pins on your Arduino, you're going to sometimes want to see the relationships between all these signals. You've got a timing problem. A typical logic analyzer will show you 16 channels simultaneously on a PC that connects over the USB. They're only like 45 bucks. And this is what I'm talking about. You can actually look and see all of the signal relationships on the pins if you're trying to do some timing. Now with development systems, Usually you'll start with breadboard and jumpers and whatnot. Those of you that have worked with breadboard and jumpers realize that those wires come loose and you end up with a really big mess over time. For me, once I moved off of the breadboard, I discovered this FazeDock workbench product. They're actually here in building 4, booth 4108, 4208. And Chris, are you here? Yeah. Chris Leyenbauer is the owner of FazeDock, and he's got some good stuff back there, and we'll be talking more about his stuff in a little bit. But the workbench shown here is what I call a breadboarding system on steroids. It uses a system of interchangeable component platforms known as clicks and slides, and you can customize it to suit your prototyping needs. For example, when I was doing one of my books, what you're seeing here is actually the prototype of the AR40 rotator controller. That whole thing will simulate an AR40 antenna rotator. And I built it on the FazeDock there. I reviewed this in the April 2020 issue of QST, and Chris has them back there at their booth. Also, Dr. Arduino has stepped into this game. This is a great way to get into this without having to buy a lot of parts. All of these have been reviewed in QST. The Pioneer is their great way to get started. I call this the starter kit. It features several onboard components, often used in your Arduino projects. I reviewed this in the November 2020 QST. It cost $99. And as you can see, it's got pots, it's got LEDs, it's got switches, it's got the 8 LED strip, and you can build projects. It's got the ultrasonic range sensor there. So you can build a whole bunch of basic projects with this. And then, of course, tie it in with a click and a slide. You can add this to your FazeDock, and now you can build out from even that. The nice thing is with things like this and the workbench, when you're done, take it off the bench and put it away. You don't have a pile of wires and stuff to clean up. You can leave your project put together. They also have a cover so that my demons can't open it up and build their own projects. But their next level is the Explorer. This is also an Arduino and Uno and Nano based system. And this is a great next level development system. This was reviewed in the January 2021 QST. It's $189. And finally, as you move up and beyond the Uno and the Nano, which are the basic Arduinos, you're going to look at something like the ESP32 from Expressive. This is a high-powered microcontroller, very inexpensive, but we'll cover those in a minute. But it's great for creating those more complex projects that you're going to do. Excuse me. This was reviewed in the June 2023 QST, and it's about $300. The next thing you're going to want to do, and don't be afraid, learn how to read schematics. How many of you have looked at a schematic, put it down, and said, I don't understand, I don't want to know? Yeah. This is for Einstein. I'm not Einstein. Leave it alone. But in reality, they're not that difficult. All it is, it's a symbolic representation of the components and connections used to create a project. SparkFun and Adafruit have excellent tutorials on their websites on how to read schematics. A quick search of other websites will give you just a whole bunch of how to read and schematics. There's also several books out there on learning to read schematics. And this will help you understand basic electronics, because now you can look at the diagram, and as you do it more and more, you'll start understanding how these connections and how everything interacts and works together. The ARRL handbook is another excellent place to find all of this basic information. And as I mentioned before, parts is parts. For all intents and purposes, when we're in hobby use, the parts quality is the same no matter where we get them. While you can spend more for parts from places like Adafruit, SparkFun, Jamco, DigiKey, as a general rule, there's not a lot of difference between these parts. And so save yourself some money. Get them from Amazon, eBay, AliExpress, Banggood. That's 99% of my parts suppliers. Now, we will talk about some of the high-end parts suppliers like DF Robot and some other really cool things that have come out. And you're going to be amazed at some of the things these folks have. And, but many of these suppliers also have free or low cost, shipping. I got Amazon Prime, so whatever I order off Amazon, I don't pay shipping. And we want just some basic parts. You'll want this stock on hand. Why? Because we get tired of singing Mr. Postman waiting for our parts to get in here. Parts from overseas take about 2 to 3 weeks to come in. The more we sing that song, the more people don't like us. But I have a printed list of parts, and I did not bring that in from the car. I apologize. But I'll show you here, and anybody who wants that list, just send me an email at kw5gp@arrl.net, and I will send you the list. But they're also shown on the following slides. There's typically only a handful of resistor values that I use on a regular basis. 220 ohm, 330, 470, 1K, 2.2K, 4.7K, 10K, and 100K. That will cover you for 99% of your resistor needs for your projects. I tend to use the 1/8 watt because I'm not dealing with a lot of power. I'm dealing with 5-volt logic signals. So 1/8 watt is fine. Same thing with the caps. I use 0.1 microfarad, 1, 10, 100, 1000, and typically 25 volts or higher. The way a cap works is the voltage is the minimum voltage or the maximum voltage that capacitor can handle. So as long as it's above 16 volts or thereabouts, you're not going to hurt yourself. But if you exceed the voltage rating on a cap, you can blow the cap. And it makes a nice little firecracker pop. Diodes. I like power rectifiers. I use the 1N4004. This is, shoot, I forget the voltage rating on it, but they're 1 amp diodes, and they're good for power. You got your small signal, the 1N4148. These are for like your RF receivers and things like that. Schottky diodes, very same thing. They're very low loss diodes. Then you got your Zener diodes, which you can use for voltage regulation, and I usually get the 4.7 volt for that. Transistors, there's only about 2 transistors that I use, the 2N2222A and the 2N3904 NPN. I use those for switching predominantly. 90% of what I do is digital. I really don't play with analog. My weakness is analog. I leave analog to the Einsteins out there. Voltage regulators and LEDs. Since the average microcontroller onboard regulator can only supply about 800 mils, and it may only be 3.3 volts, you usually are going to need an external voltage regulator for some of these big projects. Get you an LM7805 for 5 volts, LM7812 for 12 volts, the LD117 for 3.3 volts. The number one thing we're going to want to play is we're going to use LEDs. We're going to use LEDs for indication, just to have fun with. They're great learning tools. I get the 3 and 5 millimeter in red, green, yellow, and also the RGB, which give you all 3 colors, red, green, and blue. And I also use the addressable LED strips. They're WS2812 types. These are 8 LED on a stick, or you can get 10-meter long strips with 100 LEDs on them. And they're all addressable, so you only need one data line to actually turn on all those LEDs. And you can turn each one on individually, set its color individually, fade it individually, just all sorts of cool things. For pots, I typically use the 500K, 1K, and 10K. I use the standard 3/4 turn and 10 turn trim pot values. Whatever style and design you're happy with, whatever you want to do with your project, but I get a little bit of all of them. I use 5 and 12 volt relays. Why do we use 12 volts? 99% of our ham gear is running on 12 volts. So that and 5 volts, I got my relays covered. I get the standard and the little itty bitty dip read relays, but any relay will do. For my power, I use DC power jacks and also power pole connectors. I buy power pole connectors by the hundreds. They're just real easy to interface and work with. I also get rotary encoders. Those are great for controlling things. They make great tuning knobs and things of that nature. But the number one thing I like to use are these color thin film transistor displays. Typically the 1.8-inch ST7735 type and the 2.2-inch ILI 9341 type. Most of these displays are designed for 3.3 volts. In the Arduino world, they are pretty much everything is going 3.3 volts. But since the Uno and Nano are 5 volts, you're going to probably want some level shifters, the TXB 0108 3.3 to 5 volt level shifter. This will actually level shift bidirectionally for you. And you could use resistor voltage dividers, but this bidirectional level shifters really work very nicely and they're not very expensive. There's some really cool TFT display libraries out there that you can use in your sketches. This is Duduane's KV4QB's version of the SI5351 direct digital synthesis VFO display that was designed by TJ Uebo, JF3HZB. And you remember the old rigs that, as you turned the dial, you literally had 3 speeds on the dial as it turned. The lower turned faster, the upper turned slower, and the top one turned even slower. That's what they're duplicating here on a thin film display. And that library is available on GitHub at Digital VFO with Analog Dial version 2. And I plan to incorporate this in some of my projects, but that is an absolutely gorgeous display for a radio. Some of the other displays I like to use are the organic LED and the Nokia 5110, although they've kind of fallen out of favor. But the 5110 and the organic LED, they're smaller displays, but they're able to be seen in broad daylight, and they use very low power. Now, those of you that are familiar with the e-ink displays, there are some things that aren't really well known about those. I prefer to avoid them right now because the manufacturers state do not update more often than every 3 minutes, or it will physically damage the display. Yeah, I don't want to build a project that if I update it every 2.5 minutes, at some point it's going to kill itself. No, if I'm going to break apart, I'm going to do it on my own. I don't need help. But while these do produce a high-quality graphic image that's retained when the power is turned off, that limitation is something you need to be aware of. These displays are also slow to refresh. They typically take 1 or more seconds to refresh the screen. And as per the Adafruit Learning Guide for e-ink displays, refreshing or changing the display more often than every 3 minutes can physically damage these displays. For this reason, if you're going to incorporate them in your project, do not forget that limitation. They may overcome this with time, but I'd hate for you to build something, spend all your time there, and then have to swap out the display because you keep breaking it. Don't blame me, although you will. But until they get this figured out, I would tend to avoid the e-inks unless you're going to do something like a name badge or something that doesn't update very often. The modules that you're going to want to get, the AD9850 direct digital synthesis module is great for RF generation application. It generates a beautifully clean sine wave from 0 to 40 megahertz with an accuracy of 0.0291 hertz, and that thing don't drift. Yeah. So you're going to be on better frequency than most everybody else with it. The SI5351A is also very similar. It can generate frequencies from 8 kilohertz to over 150 megahertz, and it's got 3 separate outputs. Actually, the chip has 8, but most modules have 3 outputs. The difference here is that output is a square wave. What happens when you transmit a square wave? You got harmonics and trash all over the band. Usually a visit from the FCC at some point. The output being a square wave, you're going to need to filter or smooth that if you're going to use it. I personally prefer the 9850, but a lot of folks use the 5351 because it's cheaper. And if you filter and smooth it correctly, you're not going to have any problem with it. Voice modules. You heard me talking about DF Robot. They have a speech module, the Gravity Speech Synthesis module. This is great for those text-to-speech applications. It's got an onboard speaker, and as you can see at the very bottom of the board, they also have external speaker connections. You talk to it using a standard TTL serial interface or the I2C bus. You also have the ISD 1820. This is a voice recording and playback module. It's got a microphone on it. Has a recording capability of 8 to 20 seconds with a sample rate of 3.2 kilobits per second. It's got an on-chip 8-ohm speaker driver. This is great if you want to build yourself a little contesting memory. Get 1 or 2 or 3 of these and put them together and give yourself 3 push buttons, and guess what? You got a 3-message contest keyer. So now you know how I play field day. I cheat. I usually rack up about 1,000 contexts on field day, but I think I've only manually said nothing but the report. And if I could get the Arduino to do the report for me too, I'd let it do that as well. But yeah, field day's over and I still have my voice. The voice recognition module from Arduino is a shield that is a standalone voice synthesizer and speech recognition shield for the Uno. It supports up to 150 full sentence voice commands, and it's independent of the speaker. So anybody can talk to it and will understand you. It's got a built-in microphone. It also supports English, Spanish, and German. So guess what? You could use this to translate between English, Spanish, and German. Speak to an English, play Spanish. So you can build your own little voice translator. The DF Robot Gravity Voice Recognition Module. This supports 121 built-in command words and allows you to add up to 17 custom command words. And I did not add this. This came directly from their documentation. It even includes cat meows. It will connect using a standard TTL serial interface or the I2C bus. And now, how far are we from a voice-controlled shack or cat feeder or anything along that line? My concern is when the cats figure out that the feeder also controls the rig. And I come home and find out they get DXCC before I do. I will not be happy. There's also some really cool modules here. The DF Robot Gravity Gesture Sensor. This can recognize 12 hand gestures with a sensing range up to 30 centimeters, which is nearly a foot. This means that this can identify 12 separate hand gestures. So now think about this. I'm building a CAD interface for a radio. Let's tune up, let's tune down, let's kick the amp on. Now let's turn the amp off. There you go. All by hand gestures. Let's rotate my antenna. Let's go left, let's go right. All from a gesture sensor. And this also connects via standard TTL serial interface or I2C. Let's just take a moment and think, what can you build just with hand gestures? There's so many cool things you could do. And we're going to talk about some really crazy things that you can do, because part of this, the whole reason I'm here is I want to put ideas in your head. I want you to go home and say, my gosh, I've got a page-long list of projects I want to build. And this is part of what I'm doing here. I'm giving you ideas on which I want one of you to come back next year and say, I built that CAD interface. And now I'm sitting in the living room and I'm working CW. And the rig's in the other room. And believe me, we're going to show you how to do that. Here's another module. While many of the newer microcontrollers do have integrated Bluetooth support, you might also want to have some of the old Bluetooth HC05 modules for the ones that don't have built-in Bluetooth support. And there's a reason for this. These modules can be used as either a Bluetooth master or a slave. And we're going to discuss a really interesting use for these in just a little bit. There's a special project. And those of you that have been to ARRL headquarters and worked W1AW, you might be aware of where we're going here because you used it. And I bet you didn't know you used it. But we can also add some satellite technology. We can use the GPS module in several different ways for our microcontroller projects. In addition to telling me where I am, what can a GPS do? Very, very accurate time. What do we do that needs accurate time? FT8. If we're out in the middle of a POTA activation and we can't get accurate time, our watch battery died, what are we going to do? Guess. No, we can use a GPS and it will give us accurate time. We can build a Stratum 2, which is about as close to atomic time as you can get, time clock out of a little $10 GPS module and a $2 or $3 display. Most of these come with an internal antenna, but some of them also have an external antenna in case you need a little extra sensitivity. And these things are about 20 bucks. Here's a really cool thing. Those of us that are into weather. How many of us like watching weather and building weather things? This wind sensor comes from moderndevice.com. It uses a unique method to accurately measure wind speed. When you measure wind speed, what do you typically think of? Those spinning cups. Do you really want something mechanical when we're in the electronic era? Let's use this. It uses what's known as a hot wire anemometer. What happens when wind blows across something? It cools it. So what this uses is how much current does it take to keep this little component heated to maintain the temperature as the wind goes. And it uses that difference to determine the wind speed. And it comes with two different models. And these are highly accurate measurements, by the way. The Rev C model measures wind speed from 0 to 60 miles an hour, so pretty much anything. But for those of us that like to live dangerously, you've got the P model that will measure up to 150 miles an hour. You are more than welcome to stand outside and hold that up. I will not be there. But the thing is, now you can build your own severe weather station. With this little module out there, it's not going to be spinning cups that are going to turn your roof into a helicopter. It'll just be a very small module that can withstand the wind, and you'll be able to see what the wind is like at this location. Uh-oh.
Is that omnidirectional?
No. Actually, I take it back. It may be. I've never really tested it, but generally, but see, because the actual sensor is right there. So theoretically, I would say yes, it could be omnidirectional, but I personally have not tested that. Good question. I'm going to have to go home and find out now. But to complement that, let's get a lightning detector. But the cool thing about this lightning detector, it will detect lightning at a distance of 40 kilometers. This is 24.8 miles. And you're going to say, who cares? Well, you've got a storm coming. Don't you want to know how far away it is? Let's say you built this for your friends at a golf course. 25 miles gives them a chance to get off the course safely. Gets everybody a chance to get out of the pool safely. Gets everybody a chance to get away from the field day site safely. At a field day in Memphis about 8 years ago, we had horrible storms the whole weekend. As a matter of fact, the National National Guard folks that we had with us recommended evacuating the site because the thunderheads were like 45, 50,000 feet. It was ungodly strong. And no, we worked field day. We stayed. The whole weekend was lightning storms. But in between storms, we had this lightning detector. So when it was not detecting lightning, we were out working the rigs. As soon as it detected lightning, we all went to safety and covered the rigs.
Does it give distance or azimuth or anything like that?
It will tell you the distance.
Okay.
It tells you the distance to the leading edge of the storm. It uses an algorithm to calculate that. And it can detect cloud-to-ground lightning and cloud-to-cloud lightning. And it's also resistant to man-made noise. And it uses the I2C and the SPI interface. And it,
Require an antenna.
actually, I was just going to say that. You see that little numbered thing at the very bottom there? That is actually the antenna. It's one of those old little AM bar type antennas. And the reason for that, how many of us remember back in the AM days with those big ferrite bar antennas inside the radio? That's what that is on a minimum scale. Why is this? How does this thing detect lightning? They have determined that lightning at 500 kilohertz has a signature that can be analyzed with digital signal processing. And this chip is analyzing and looking for lightning on 500 kilohertz. So it's a 500 kilohertz signature looking for a specific signature. You've also got an MP3 player module. This uses a little micro SD memory card so you can store and play MP3, WAV, and WMV files. This is for serious contesters. Now you got MP3 files. How many? You know, you can do all sorts of things with MP3 files and projects. Think about your projects. Now you can literally have this thing talk to your dog while you're away. You know, put a sensor, you know, the dog's up on the counter, have the sensor tell the dog to get off the counter. Doesn't work with my cats, but I thought it would be worth a try. But it communicates using the standard TTL serial interface. And the files can be sorted in up to 100 different folders of 255 MP3 files apiece. So you've got an awful lot of audio choices here. You can literally make your own AI bot to converse with you with this module. Some of the other modules, there are so many available that would spend the rest of the day here if we covered them. I usually purchase these on an as-needed basis from places like SparkFun, Adafruit, DF Robot, eBay, AliExpress, and Banggood. And of course, when I order one, I usually order 2 or more. Why? I need a sacrificial lamb. So, gotta have a spare because I'm not gonna, if I'm on a project, I don't want to wait for a replacement. Also now, let's talk about building supplies. You're gonna want some basic supplies when you go to construct your project. I don't go direct to circuit boards. In fact, at this current time, I don't build my own circuit boards. I need to, but I don't. So what I do, I use prototyping boards. For me, what I have found is these little 60 by 80 millimeter prototyping boards. I love these things because they're small. Usually most of my projects fit on them, and they fit inside the SolarBotics safe and mega safe enclosures that we'll see in a minute. And for Arduino projects, I like to use what they call a prototyping shield. That is a prototyping board that mounts on top of an Uno with the header pins and everything like that. So that's pretty much where I build. To wire it up, I use 30 gauge Kynar wire on the backside, and you can get this wire in many, many colors. So now you can color code your projects, you know, black for ground, red for 5 volts, orange for 12 volts, things of that nature. White I use for signal lines. And so now you can look at your project and troubleshoot it because you can see where the wiring is. And you know instantly this is power, this is ground, or this is data. And I put everything in sockets. Why? Stuff makes smoke. I prefer to put it all in sockets. This makes it easier to replace that component in case I do make a mistake. And I have miswired a pin or two, and stuff happens. But this allows you to also easily repurpose these components. You can build a project, and when you're done, pop the Arduino off, pop everything off, and reuse these components, and now you've got the circuit board. You can always come back to that if you want to revisit that project later. And you've got, what, a $3 or $1 prototyping board that you just put off to the side and go again. These prototyping boards are very cheap. For the microcontroller modules, cables, and connections, I use the DuPont style 2.54 millimeter headers shown in the top there. And those also are header pins and sockets. You can cut those to length as needed. And then I build little cables using ribbon cable and the socket headers. You can get these. I just bought a 8-pin version. I bought 100 of them for like $3. Ribbon cable, if you scour a Hamfest, you can usually find a guy with a box of old floppy and hard drive cables. Those make absolutely wonderful signal cables. Just hope I don't find that table before you do. And then to mount the finished board, the TFT display, and other components, I use the SolarBotics enclosures, and I use 2 millimeter screws, nuts, and washers, and 440 screws, nuts, and washers. I also like to have the matching nylon and fiber washers for insulation when I need that. And as you can see here, this is how the circuit board mounts inside one of the SolarBotics enclosures. And you can see how the TFT display is screwed into the top of the box. This is the enclosure I've been talking about. But when you build your projects, you're not limited to what I tell you to use for enclosure. I have seen cake tins used. I have seen Altoids tins used. Any enclosure will do. My personal preference is these MegaSafe acrylic enclosures from SolarBotics. Those of you that know how to 3D print and laser cut, there are a million things on Thingiverse that you can use to download and cut and burn your own and print your own enclosures. So you can find just about anything. And these 3D designs are everywhere. Chris probably knows more 3D designs on enclosures than I'd ever know. But I prefer the Solar Robotics ones. They're easily assembled, and I just standardize on those. And for finishing touches, one of the ways I've found to finish up my projects to make it look really good, go to Hobby Lobby. They actually have inkjet, and also online you can find laser printer water-soluble decal sheets. Those of us that have built those plastic models as kids, remember those decals we had to slide off and put on, and we were always messing them up and whatnot, but still. You can now make your own water slide decals. You can make them in any color. The ones I've shown here are black and white, but you can use them with inkjet and laser. They're available in both. The only difference is when you use the inkjet, you have to spray a fixer on it before you get it wet, otherwise the ink will smear. It's the only difference. And as you're seeing here, these are actual finished products. That's a 40-meter transceiver with the tuning dial on an encoder and everything, and you can see everything. There's a logo that I use on the side. And you can make these things any size, and they're all water slide decals. So they really make your project stand out and look a lot better. So now, what do you want to build? If you're starting out, that's probably going to be your biggest question. That's where we started today. There are several places you can go and find easy-to-build projects. You can find them in the many Arduino and microcontroller books, including mine. You've got SparkFun, Adafruit, Instructables. Others have very easy to build projects on their websites to get started. Microcontrollers have several methods of talking to the outside world. These are important to learn. In addition to the digital and analog I/O pins, you've got the I2C bus, which is also the inter-integrated circuit. This is a 2-wire plus power and ground bus. This is an industry standard bus protocol that these modules I've been talking about will use to communicate. Think of it as a sort of serial, but not quite serial data. But it's an industry standard, so a lot of these modules support that. And then, like the TFT displays, support the SPI bus, and this is serial peripheral interface. And this is another industry standard bus that's available on the Arduino and other microcontrollers. And all the modules and external components will communicate using that. And this is all standard and it's built in. You can get software libraries to support all of this. You also have the 1-wire bus. This is a bus protocol that uses a single wire plus a ground to provide power and data to the actual device. There are actually 2 versions of 1-wire. One from Dallas Semiconductor and the other from Maxtech. These devices are not compatible, so if you're going to play with 1 wire, be sure that the devices you're using are compatible to be on the same wire or put them on separate I/O pins. But that's the only difference. So basically, Dallas Semiconductor or one or the other is you can put them all on 1 wire, but the others they run on 1 wire, but they have to be discrete. You also have this is where I'm heading to play. You've got the controller area network. How many of us have played with the controller area network? Everybody, raise your hand. You drove here, didn't you? That little ODB connector in your car the mechanic uses, that's the CAN bus. So now you can hook this to your car and grab data from your car. So now you can feed telemetry to your APRS transceiver direct from your engine and pass on your speed and all that other stuff directly to it. You can do all sorts of cool things with the CAN bus. And then, of course, you've got the standard UART technology, which is your old RS-232 using logic level voltages. But now, which microcontroller do you use? You've heard me talking about the Uno and the Nano. There are so many more. These choices keep expanding daily. I could spend the rest of the month here talking about all of them and we wouldn't find it. But as a general rule, you start out with the Uno and Nano. That's a good starting point. It's inexpensive. And work your way upwards from there. You will be surprised how many projects you build fit the Uno and Nano platforms. It uses an 8-bit, 16 megahertz CPU with 32K of flash memory, 2K of RAM, and 1K of double EEPROM. That's an absolutely huge computer. You know, when you go back to 1973, maybe. But actually, believe it or not, in '73, that was probably a lot of RAM. I don't know if I have that slide on this presentation. We'll know in a minute. But basically, in that era, with this kind of microcontroller, this is more powerful than supercomputers we used to put man on the moon. So, but you've got 14 digital I/O pins and 6 analog input pins. It's powered by 7 to 20 volts DC or over the USB port, and it costs a whopping, what, $3. You've got the STM32. This is a family of microcontrollers that are 32-bit and are based on the ARM Cortex-M CPU. The Blue Pill version has a 72 megahertz CPU, 64K of flash. Hey, we're getting up to the PCXT era. 20K of RAM, 32 digital I/O pins. 12 of those can do pulse width memory. Pulse width modulation. You've got 14 analog input pins, 3 serial UART pins, 2 SPI buses, 2 I2C buses, and it costs a whopping $3. I was going to say, it's not my time yet. Upgraded version of the 8266. It's running, that's the ESP32. It's running the Tensilica 32-bit CPU. This goes up to 240 megahertz. It's got up to 16 mega flash, 38 to 77 I/O pins. If your project won't fit in there, you've got a really big project. Got to up to 18 12-bit analog pins plus 2 8-bit D to A pins. It's got onboard capacitive touch switch sensors, 4 SPI channels, 2 I2C channels, and 3 serial. You've also got 8 channels of infrared remote control. So now you can add infrared remote control to your projects. So now you can control the TV set. You've got 16 channels of pulse width modulation. It also has an integrated Hall effect magnetic sensor. This also costs about $3.
It's also got
Bluetooth and Wi-Fi, yes. You've got the Arduino Nano 33 BLE. This is actually pin compatible with the original Arduino Nano, but it operates only at 3.3 volts and it will not support anything 5 volt. It's a 64 megahertz 32-bit CPU, 1 mega flash, 256K of RAM. So now you can build some pretty hefty projects with this thing. Got 8 12-bit A to Ds, and it also has a built-in 9-axis inertial measurement unit. So now this can detect motion in 3 axes. It's also got Bluetooth and Bluetooth BLE, and it's $26. You've got the Nano ESP32, and this again is also pin compatible with the Nano at 3.3 volts, but it is not 5 volt tolerant. It'll go up to 240 megahertz with 32-bit ESP32 CPU, 128 meg flash, 512K RAM. This is a horse. 384K of ROM. It's got Wi-Fi and Bluetooth as well. It also has Arduino and MicroPython support. We'll get into that in a little bit. It's $20. You've got the Arduino Nano RP2040. Those of you that saw my seminar last year, how we were under the Raspberry Pi Pico, we'll talk about that in a minute. But it is pin compatible with the original Nano, but again, operates at 3.3 volt, is not 5 volt tolerant. It's got a 133 meg dual core processor, 16 mega flash, Wi-Fi, Bluetooth, Bluetooth BLE. It's got a built-in microphone and a 6-axis inertial measurement unit. And it also supports the Arduino and MicroPython, 22 digital I/O pins. But it's up at $30. That's a little expensive if I'm going to make smoke. So, but you've also got the Uno R4. This is a 5 volt tolerant. This is literally a drop-in replacement for the Arduino Uno. It's a 48 megahertz CPU, 256K of flash. The cool thing I like about it though is it is directly replaceable. So now you can take a 16 megahertz Uno and turn it into 48 meg. It's also got onboard Wi-Fi and Bluetooth. You can select that A to D to be 10-bit or 14-bit. It's got onboard CAN bus, real-time clock. And it also supports the Arduino and MicroPython. They've got 2 versions, one with Wi-Fi and one without. But again, we're at $20 and $27, so we're still a little bit up there. But now here's my favorite, the Raspberry Pi Pico. 133 megahertz dual core Cortex M0 Plus, 2 meg of RAM, 2 meg of flash, 256K of RAM, 26 digital I/O pins, 3 12-bit A to Ds, all those cool buses. It's got an on-chip real-time clock and temperature sensor. Now we're down to $4. This is one of my personal favorites, but there's some other reasons why. The cool thing about the Pico, the language that it runs on can be changed with a simple press of that boot select button. In addition to the MicroPython and CircuitPython and C++ that it comes with, you can now add the Arduino ecosystem to make it plug compatible with the Arduino IDE. And there are now 2 versions of BASIC, MM BASIC and Piccolo BASIC. So now we can go all the way back to 1980 and play with BASIC. So, hey, there are some of us that miss BASIC, okay? I'm one of them. I mean, think of the programs we wrote in BASIC back then. We wrote complete finance and accounting systems in BASIC. Let's get real. But it is still my personal choice for high-end projects due to speed, I/O capabilities, language, versatility, and the price. By the way, while I'm here, let's take a quick break. Has everybody gotten a card for the drawing and the bag? Okay. Okay, pass the bag on down.
There's no cards. We don't have any cards.
What now?
Ran out of cards.
We only got 3.
Only got that far with the cards?
Yeah.
Let's see if we can fix that. I'm glad I asked. We got you covered. All right. We'll do it this way. Yeah. Just take a ticket, tear it in half, and keep the stub. Don't have to fill your name out. So those of you that don't have the...
Does it matter what you want to give them?
No, it doesn't matter. They all have the number.
And these are for the people that didn't put the thingy in the bag,
Correct.
right? Okay.
Yeah, if you put your ticket in the bag, you're already entered. The bag's going to pass around.
Oh, you have the bag?
Yeah, we'll just pass the bag on down.
Oh, I'm sorry. Yeah. Thank you for giving me the bag back. Okay. Who else?
These are 2 of the prizes we're going to be giving away. These are my current Arduino books. And my new one is coming out in about 3 weeks. We'll talk about that. Yeah. Tear off one, keep one, and put one in the bag.
There's the bag.
Oh, well, you're going to need to pass that around for people to drop their tickets into.
Well, no, we're gonna drop this one in.
Right. Okay.
Giving it to you.
Okay. I got it. I'll stay out of it. He's got it. At this point, I only tend to mess stuff up. Thank you. This was a test to see how many of you were paying attention and how many had fallen asleep. And while he's doing that, we'll continue on a little bit. We're in good shape. At some point, you're going to want to design your own microcontroller projects. You may also want to share your work with others. Yeah, let's go ahead and catch up on this. Does anybody have any questions to this point? Yes, sir.
I guess you kind of already answered this. Do you have a preference between Arduino or Raspberry Pi?
Well, there's 2 different animals there. The Arduino is a microcontroller. The Raspberry Pi
Microcomputer.
is a microcomputer that runs Linux. I prefer the microcontroller because they're 2 different critters. One's a computer, one's a controller. Think of a microcontroller as the engine management computer in your car. And a Raspberry Pi, it's a computer. It's a PC in a box. Yes, sir.
So, I've been trying to program the Pico in C++, and I just find that all the libraries they're not compatible.
Right.
I mean, they seem to work okay in Python.
Yes.
So I switched over to using the Nano ES232, and that seems to be green Pico.
Yes. Yeah, the libraries aren't quite up there yet. And but they're getting there. And I'm viewing the Pico as a great way to transition from the Arduino up to Python, because Python has been considered the basic of the modern era. It's really easy to work with, and I think at some point we're all gonna all be on Python. It's just slowly getting there. I had that same discussion last year. I still have not learned Python, by the way. Any other questions? Oh, yeah.
You're not doing Python, are you doing all your writing in C or?
I'm using the Arduino IDE, which is a C++ version. A simplified version of the C++, and I'm a simpleton, so I like the simple stuff. But at some point, you're going to want to document your work in a standard format. There are several free schematic generation programs out there, so you can document and share your information with others and put them on the internet and everything. You can also use these to create the files you will need to make your own circuit boards. Up to this point, I have used the free version of Autodesk's Eagle. However, they're transitioning Eagle to their Autodesk Fusion in 2026. It's still going to be free for personal use with some limitations, and it'll still be free for students, educators, startups. But why do that? KiCad is a free open source software suite for schematic capture, PC board layout, circuit emulation, other built-in features. I personally am transitioning to KiCad, and I really recommend everybody go to the KiCad open source if you're going to be creating schematics. It's free, and it's really well supported. If you want to practice with the Arduino and other microcontrollers, there are several web-based Arduino simulators that you can use. You don't even need an Arduino now. Arduino Simulator is an open source Arduino simulator written in JavaScript that will run code directly in your web browser with no other hardware needed. It supports the Uno R3, the Mega 1280, 2560, and the Nano V3. WowKey is a browser-based simulator that supports the ESP32, Arduino, and Raspberry Pi Pico RP2040, and these are all online browser-based simulators. Here's some more new technology. Meshtastic is an open source project that uses inexpensive LoRa, which is long-range radio technology, used to create a long-range off-the-grid communication network. This runs on the instrumentation, scientific, and medical bands, and they have a distance record of 254 kilometers at 415 and 900 megahertz. You can automatically form a mesh network to rebroadcast messages to other nodes, so think of it as a variation on the old Hamnet mesh networking. And it's supported on the ESP32, the NRF52, and the RP2040 microcontrollers. So what's next? My book, More Arduino for Ham Radio, is currently available from ARRL. After this seminar, I will be at the ARRL booth, and I will sign books and talk to you if you want to come over and have fun. ARRL is in the process of publishing my latest book, The Best of Arduino for Ham Radio. This should be out in about 3 weeks. And also, we'll talk about that one in a second. ARRL and I have worked out a plan for future books. These are focusing on ham radio applications for the Internet of Things and the Raspberry Pi Pico. I also have an upcoming QST article about a Bluetooth wireless CW keyer. And this has been in operation at W1AW for over a year. No, wait a minute. What? I said wireless twice. What is radio? Wireless. What is Bluetooth? Wireless. What's a keyer? Wired. Most keyers connect over a wire to what? The rig. This is a wireless Bluetooth wireless CW keyer. It uses a pair of Arduino Nanos, the HC05 Bluetooth modules, to wirelessly remote a CW keyer. Remember a little bit ago I said that you could sit in the chair in front of the TV set and work CW? We already have Bluetooth earpieces, right? So we can hook our rig and give us Bluetooth audio. What if you had your keyer sitting on the nightstand right next to you at the TV? And now you can key while you're watching TV and work while you're watching TV. And you can use your gesture sensor for the cat, transmitted over Bluetooth. This keyer plugs in. The keyer itself plugs into the remote unit. No other wires. It's battery powered. There is no wire from the remote unit to the rig. There's another unit on the other end that is plugged into the rig. Your keystrokes are transmitted to the rig itself over Bluetooth. Now here's the interesting thing when you use these Bluetooth modules. What is Bluetooth? It's serial data. It's sending serial ASCII. How am I sending key contact commands over ASCII? That's the trick. But basically what this thing does, you can key with your keyer and it will translate that on the other end to keystrokes directly into the flex radio at ARRL headquarters, and you cannot tell that there is not a wire between that keyer and the rig. It will.
Anybody else need a ticket?
Does anybody need a ticket? One in the back here and one over here.
All right.
But the cool thing is, this has been in operation at W1AW for over a year. So if you've gone to W1AW and worked CW on the flex, guess what you did? You used it. Did not know it. It has been tested up to 60 words a minute. Dave Minster has personally used it up to 35 words a minute, and zero latency. You can't tell you're not using a wired key. So this is some of the cool things you can do. Now you can literally remote your shack to anywhere. Do it from the kitchen table while you're having coffee. Elector just finished my latest book, Arduino for Ham Radio Applications. That's this book. There are no stateside distributors yet, but you can get it from elector.com or Amazon. We are working to get it stateside. And it's got 10 new projects, including that wireless Bluetooth keyer. Includes 10 new Arduino projects. This has a CW beacon and fox hunt keyer, that mini weather station using that wind speed sensor. DTMF tone encoder, decoder, waveform generators, the Bluetooth CW keyer, a station power monitor, and AC current monitor. And after all this, it is now time for me to retire. Yeah, right. What this means is I have more time for microcontroller projects, more books. ARRL has indicated they want 3 additional Arduino books. Elector has indicated they want 3 additional ones. I don't know if that's happening, but then you saw the new kid on the block. He needs to go to some cat shows. So we're probably going to take him to a few cat shows in the next year or so. But more things that have happened. Dr. Arduino has several products that are aimed to help you get started on the Arduino. Pillars of Programming is an online course they have that's designed to help you write programs in just 6 days. The Arduino Boot Camp consists of 8 miniature lessons to help you learn how to get started with the Arduino. This is available at drarduino.com. New from PhaseDoc. They have just released their Intro to Microcontrollers kit. This kit includes an Arduino Uno Project Super Starter Kit. It's got a curated selection of additional electronics components. It's got the integrated organizer to keep all your parts put away safely. It's got the Workbench 1007 base, and it's got some click connectors and slides so that you can mount them into that base. This also includes lessons, project, and code to help you learn how to program and use the Arduino and other microcontrollers. And if you go see them today, it's a $25 discount at their Hamvention booth, 4108 and 428 in Building 4. Coming soon, PhaseDoc is also developing a robotic arm kit. You can stop by their building for demos. You can sign up, be notified when it's available. This is supposed to be available by the end of late summer, but this is great to get your kids involved with the Arduino and teach them robotics at the same time. This will be a great, great kit to get started with. But your journey is just beginning. You're builders, thinkers, creators, and inventors. You are a perfect match for this microcontroller world. So hopefully I put some ideas into your head, And now you can imagine the projects you can build with all the parts and things that I've shown you today, and then go out and make them happen. It's not going to cost you a lot, and you're going to have a lot of fun. Next year, maybe they'll have me back. I don't know. I may have made them angry, but we'll see. But I'm already planning an all-new forum for next year. I don't like doing the same forum twice. The working title for that forum is Close Encounters of the Microcontroller Kind. I'm also thinking up and designing some really cool projects for that. And I'm going to ask you one question. When I say Close Encounters of the Microcontroller Kind, can you tell me you did not hear that picture? Start visioning, because that's where my head is. We are going to be doing a sound and vision experience with the Arduino next year. That's all I've got. Thank you. Do we have any comments and questions?